Well, I completed the video and discovered it was corrupted. So we'll try again. See what happens. Alright, this is going to be a really long video. I'm going to try and break it into parts. We'll see how that goes. Remember that you can watch it at 2 times speed and it doesn't take so long to watch. But this is the problem statement, okay? An unnamed high school in an unnamed town, because I realized I hadn't given anybody names, needs to generate one letter to each family that has students attending the school, advising them of the tuition owed in the coming year. Tuition per student is $10,000 with the following discounts. And by the way, remember that everything here is made up. Everything you see. It's all stuff that I just invented off the top of my head. So, I don't know what kind of a private high school would charge $10,000 in tuition, but that's life. Okay, so they can get the following discounts. If a family has more than one student, you get a discount of $100 for each student after the first one. If a student has a GPA above 3.0, then you get $20 off for each tenth of a grade point above 3.0. So if they're 3.1, they'll get $20 off. If it's 4.0, they'd get $200 off. And then if the family household income is under $100,000, then you get $100 for each thousand it is below 100,000. So, well, here's the example. Okay, so you got these 3 students. So it's $30,000 for 3 students tuition, minus $200 for the multi-student discount. Because remember, it's $100 for each one after the first one. Will has 2 complete points above 3.0. And so that's 2 times 20 gives him $40 off. Sandra has got 6 complete points above 3.0. So that's 6 times 20, $120. And then the household income we said was $91,000. So that's $9,000 below the $100,000. And so they get a household income discount of $900. And so their total tuition is $28,740. You need to generate 1 letter per family in the school, and you have the following CSV files available to you. So let's look at data. You'll notice the big one that stands out is the census file. This is census data for the whole town. And remember, again, this is just made up data. But if we look at what's in this file, so it's a CSV. There's our standard header, and so you get the address, you get the first name. Actually, this is the last name of the family. This is the first name of the first person in the family. That's their social security number, again made up. They're marked as a head of household. It's a male, age 65. His income is $26,300. There's one other person in the household, Shalise. That's her social security number. She's also listed as head of household. Female, 57. She earns $51,000. And so on and so forth. How can we tell who in here is a student in this high school? Well, we can't. There is no indication here. So maybe we better look at school roster. Actually, that one's small enough. I can just load it into the editor here. Okay, so this, there we go, sorry. There's the header line. Last name, first name, grade level, student ID, social security number. So we've got the last name, first name, this person's a senior, student ID is that, social security number is that. If you remember what's in the census data, you'll notice, so the names overlap, but Carrie Abeta. Let's see if we can find a Carrie Abeta. Now let's see, there's Joshua and Shanakwa. There's Art and Elaine. There's Michael and Andrea. There's Richard and Audrey. Who are we looking for? Carrie. The program I used to generate all this data only had a finite number of names. So there's lots of Abetas in here. And I don't know if we've gone by Carrie, but there's probably multiple Carrie Abetas as well. So you can't count on the name to be unique. but you can count on the Social Security number. And so if we search for that Social Security number, 649154025, whoops, I already passed them. I don't know how to start over with this one, so we have to just come out and start over again. Okay, so we're going to search for 649154025, and that takes us to this Abeta family, and we can see that we've got Carrie, and actually we can see Timothy is also right there. And so this is the correct family, and we could generate a letter for this family. In fact, as I think about it, maybe I'll just make it, we'll just make it a text file for the moment. So we saw that we've got the Abeta family. Okay, and we saw that we've got, well, let's see, so Carrie, and Timothy, and then if we come, well, let's keep using this over here, less data school roster. So we can see that her student ID is that, probably should have left a space there, and his student ID is that. So we're starting to build up information about these people. We forgot that we're going to need, so, oh, I lost my place and I have to get back to them. 154025. So I know there are two students. I need to get the household income, which is we already know it's greater than 100,000, so there's no discount. So I don't really need to know exactly what their household income is. But I do need to find the GPAs for these two students. So if we look at data again, we've got the census data in the school roster, but then we've got all these courses that students can be in. And if we just look at one of these, it's just a list of student IDs and grade for that class. And so if we want to see what Carrie's grade point average is, we have to go through all of the classes and find out her grade. Now in Unix or Linux, it's relatively easy. So I can just say grep that star.csv. That means it'll look for her. Well, I have to remember it's in a subdirectory. So it'll look for her in all of the class records. And so now I can see her grades for the different classes. So let's go over here and let's do 2.24, 2.47, 2.44, 2.62, 2.09, 2.1, 2.98, 2.81. So is her grade point average going to be above 3? No, because not a one of her grades is above 3. So she's not going to get a GPA discount. Well, let's see how Timothy does. We need his student ID, which is this. Datastar.csv. Okay, so he's got higher grades. So let's see what he's got. 3.92, 3.84, 3.98, 3.77. Oops, got 3 4s in a row. That makes transcribing easy. 3.67. So we can guess that his GPA is going to be above 3 because he doesn't have any grades below 3. So we'll just bring up Python really quickly here, and we'll say sum, and we'll just grab all of those. Come on, you know what I meant. These computers are so picky. Okay, so 31.18, and we can do 31.18 divided by how many classes does he have? 1, 2, 3, 4, 5, 6, 7, 8. And so his grade point average is 3.8975. Now, usually you would print that out as 3.90. But we said it was for each complete tenth of a grade point above 3.0. And so by carrying it out this far, we can see he's actually only 8 complete grade points above 3.0. So he's going to get a $160 discount, is what that means. So their tuition is going to be 20,000. I gotta count zeros. 20, 1, 2, 3, minus 100 for the multi-student discount, minus 160, and that is, we'll let Python do the work for us. So their family should be 19740. Alright? So if I were writing a test function, which I'm not going to do, by the way, sorry, but my test function should just check to see that the Abeyta family at this address has this much tuition owed. There are, well, why don't I do a test? Because it takes that much more to set up. I know, that's not a really good excuse, but that's the case. So let's look at, whoops, I don't have school roster on here. So let's look at data, because I want to do at least one more case. I don't want to just do everything off the Abeyta family. So let's look for a name that's repeated frequently. How about Belleville? So let's see. We've got to get out of there. We've got to go back to the census data. We've got to look for that social security number. And we find, okay, that's the Belleville family. We've got Elmer and Jean, but no Juan. Kind of like to get one that has more than 2 students. Of course, I guess we should do one that only has 1 student to make sure they don't get a discount, right? So let's look for this one. Because we know there's only 1 student there, no matter who that is. Okay. So the Ayes family. So let's see. Let's come back to my test data here. So that's the student's information. The address is that. And I put her name on the next line. Alright, what's her social security number? And I probably should have put a comma in there. Okay. Ah! Why did you do that? Here we go. Okay, sorry. What I meant to say was that. Okay. Oh, we need to do household income. Let's do that. So how do we do household income? We have to add up the incomes of all the people in the family. And so we've got 23,500 plus 31,900 plus Carmen doesn't make any money, but her younger sister does, and Nick's younger brother does. So that's the household income, and I need another window here. Don't know what that's from. Okay, I think that's the last time I was working on the video. So 56,500. And so they are $43,000 under, so they've got a $430 discount. Okay, did I do that right? Let's see. So 100, 1, 2, 3 minus 56,500 is 43,500, and so it's 43,000 is the delta because we dropped that last, and that gets us to $430 discount. Okay, now we've got to get her grade point average, and again we'll do that by going through all the classes, looking for her student ID, and she's not going to get a GPA discount because the only one that's above 3 is that one, and it's barely above. Okay, so their tuition is going to be 10,000 minus 430 equals, what is that? 99,570, I think. Okay, now let's find a family that has more than 3 kids. So we need to come back over here in the school roster, go down a ways. And I'm just scanning through this visually. So how about Illerson? There's 4 Illersons here. So and let's look for this social security number. That's Dwayne. I don't see Holly. Do I see Robert? Nope. Do I see Vincent? Nope. So all the other Illersons are in a different family. Let's look for Knudsen. Like I say, these names get used over and over again, so there's no guarantee that any given one is unique. So we've got Herlinda, Ishmael, do we have June there? June is not in that family. How about Levi? So only 2 of those are in that family. Well, maybe we won't be able to find somebody who has more than 3. Let's try Ludwig before we give up. I just needed more than 2, didn't I? Okay, so I've got Anatoly. Do I have Grant? Not in that family. Leah? Nope. Marcy? Okay, we've got a Marcy. It's just those 2. Alright. Well, let's just do one more random. So let's try Pearson. So it's just so we have 3 test cases, okay? So we've got Philomena, no mark. We've got Trey, is that the right Trey? 2, 20, 12, yep. And we have William, no William. So at least we got 2 people here. Alright, so let's go back to our test data. Got those 2 students at this address. Family name is Pearson. And family income, mom and dad both make a lot of money, so they're not going to get a discount for household income. Okay, these people do have a household income. Good. So we've got at least 1 case with household income. What else do we need? So now we need to get their GPAs, right? So let's grep. There's actually a reason why the find command is called grep. It's kind of a nerdy thing, but it's kind of hard to tell if is this a he or a she. Mark Pearson. Probably a he. Okay, so 2.81, 3.57, 2.82, 2.77, 3.06, 3.23, 2.86. Actually, I don't think he's going to get a discount, but we'll try it and see. Okay, so we're going to say sum. That's the right set, yeah. Well, I can just do it here, right? Divided by 1, 2, 3, 4, 5, 6, 7. Ooh! It's just above 3, but it's not a tenth of a point above. So he still should get 3.02. So he gets a $0 discount, right? Let's see how Trey does. So we're going to do grep. That. Data, star.csv. And, okay, Trey's high GPA student, so let's see what he's got. 3.15, 3.61, 3.66, 3.38, 3.37, 3.9, 3.63. Okay. So, can I paste that in correctly? Divided by 1, 2, 3, 4, 5, 6, 7. Okay. 3.52, 3.53. So he's 5 complete grade points above, so he should get a $100 discount. And they also get $100 for having multiple students, so it's 10,000 minus 200 equals 99,800. So that was an easy one to calculate. All right. Okay. Now, I want you to think about what I did to calculate each of those, because we're going to have to go through the same process in our program. All right. So we had to come up with a family that had students. So I looked in the roster to get the student information. Then I looked at the Social Security number to get the address, which is what gives me the complete family. Then I had to look in all the classroom files to get the GPA information. I had to look in the census file for the whole family to get the household income information. And so you can kind of see the way we're having to collect data and the steps we had to go through. So we're really going to reproduce those steps in the program. And by the way, let's just make these a little easier to pull. Okay. All right. So we're just going to check by hand with these 3 cases. But if 3 cases work, probably the whole program works. That's what we're hoping, right? Certainly we could write a better test, but I haven't done it. Okay. So now we're going to call this school.py. It's still there. Why is it there? Because I didn't delete it. We really want to... Oh, no, it's not. If I look, it was just in my editor buffer. That's what the problem was. Okay. Okay, there we go. So, we need to read the school roster. That gives us students by student ID and Social Security number. Then we need to read the census data. That gives us families by address and individuals by Social Security number. Then we need to read all the class files, and we can calculate GPA from there. So that's the rough outline of what we're going to have to do, and I'm going to end this video here just so we've got a nice break point.